So hello, good afternoon. So today we want to look at the product rule of differentiation. Okay. Now, if you have a function, product, we have a function y is equals to uv, where u is a function of x, where u is a function of x, and v is also a function of x. They are both function of x, right? And they are now multiplying each other. These two functions, right? Okay. So what is going to be the differentiation of this function? Okay, now this y can also be written as f of x is equals to uv, right? Okay, and from our first principle, right, the formula for deriving the for getting the derivative of functions from first principle is this: f prime of x is equals to the limiting value as dx tends to 0 of f of x plus dx minus f of x over delta x. This is the formula, right? So with this formula now, we can use this formula to actually solve this problem, right? Okay, so this is going to be the limiting value as delta s tends to 0. Now this one, if we want to write this is going to be written as, we have u, and then when it becomes f of x plus dx, it's going to be u plus du, right? Then this is going to be v plus dv, right? Then minus f of x, which is of course uv. Then everything over dx. This is how we're going to write it. Okay, so we'll now expand this, and it's going to be the limiting value as delta x tends to 0 of u times v, that will be uv, u times dv, that will be u dv, right? Then u times du times v, that will be v delta u. Then delta u times delta v, so that will be delta u and delta v minus uv, right? Everything over delta x, right? You see that this is going to cancel this, right? That will be 0. Now from here now, this is going to be, this one can be written as, you can use this to divide every term, right? Okay, this is going to be limiting value as delta x tends to 0, u delta v over delta x plus v delta u delta x, right? And then plus, this is delta u delta x delta v, right? All over delta x, right? Okay. Okay, now this is now, if we look at this very well, this can be, we can multiply the top and the bottom by delta x, such that we have delta u all over delta x. So this can be delta x, delta x. So this is now multiplying so that we can have delta u over delta x, delta v over delta x, right? Okay, now if we now find the limit of this, the limit of this means as delta s tends to 0, as delta s, as this one tends to 0, what happens to delta v over delta x? It tends to dv dx. Then also delta u all over delta x, it tends to du dx, right? Okay, as this tends to 0, this tends to dv dx, and this tends to du dx, right? If we now substitute everything in this, becomes u delta v for the limit to go. So this is going to be u the v dx plus v the u dx, right? Then plus, this is 0, multiplying, of course, the u dx times the v dx. 0 multiplied by anything here is 0, right? Okay, so this renders this 0. So our f prime of x is going to be u the v dx plus v the u dx. So that is the formula for product rule. So the formula now is f prime of x is going to be u the v dx plus v the u dx for product rule. So this is the formula. So this formula is what we now apply for any product of two functions, right? Okay, and this can be extended to more than two functions. So if we have three functions multiplying, then it means we can still apply this product rule upon that product. That is, we take two, we multiply, we do the products. One will be u, the other one will be v, and then we carry out. We use this particular formula to do that, and that gives us the answer. So this is how we carry. This is the formula for the differentiation of you know um functions, that is u and v, which are functions of x. Okay, thank you.